Hi, welcome to a short video on the data analytics lifecycle. Within this video, we're going to discuss 4 different areas. We're going to discuss the key phases of a data analytics lifecycle. We're going to apply the data analytics lifecycle to a case study scenario. We're going to describe the purpose of an analytics plan, and we're also going to name the 4 core deliverables for a successful project. Okay, so hopefully we get through all of these 4 different areas within this session. Alongside this session, there's going to be some more resources for you to have a look at. We've obviously got the book, the Dell EMC book, for you to go through as well. So the topics we cover within this session are just going to be broad overviews of the different types of things you should be looking at, and then you should be expected to do some further research outside of this session. So, a data analytics problem, what is your approach? One of the key things to consider is how do you approach your analytics problem? How do you plan an analytics project to address a business problem? And do you follow a methodology or some kind of framework for an analytics problem itself? So you've got an analytics problem and you've got a business problem, okay? So the business problem is the problem within the business that you're trying to solve. An analytics problem is looking at that business problem. What are you then going to do? Okay, so it could be an analytics problem, could be something that isn't directly related to the business problem, but it then helps you design something which could then solve the final business problem. Okay, so analytics focus on developing new insights and understanding of business performance based on data and statistical methods. Organisations can apply their big data to uncover new emerging trends, identify potential business opportunities, and discover new ways to gain competitive advantages. Consider how your organisation currently addresses analytical problems and projects. So, as we've discussed, all this slide does, it just gives you the definitions between the 2 different things. So, a big data analytics problem focuses on, or just a normal analytics problem, focuses on looking at the data and statistical methods that you've uncovered from the business. You can then use them to look at trends and patterns, and then you can identify ways to fix business problems. Okay. So there's a number of roles within an analytics project that you need to consider. So you've got a business user, a project sponsor, a project manager, a business intelligence analyst, a database administrator, a data engineer, and a data scientist. All these different roles generally are done by individuals that focus on one specific thing on a big organisation. If it was a smaller organisation, you might find certain people cover a number of these roles as well. Okay. One thing to consider here though is just that each individual role has a different role to play within the bigger picture. Okay. So let's quickly go through them. So the first one that we're going to discuss is the business user. So this is a person that when finished will take your results and turn them into positive outcomes. Someone who benefits from the end result and can advise the project team on the value of the end result and how the project results will be operationalized. So what a business user does is it takes your data analytics problem that you've found trends for and it puts it into operation. So it might be setting something up based upon your data, for instance. The second one is a project sponsor. This is a person who generally is paying or approving the bills, or a person who chooses out of range of projects which ones are going to be performed. So you could have like several different projects running, and these are the people that are going to look over them and work out which ones we're going to foot the bill for, or we're going to give the go-ahead for based on the business needs. So they're responsible for the genesis of the project, providing the impetus for the project and core business problems. The project sponsor generally provides the funding and gauges the degree of value from the final outputs of the working team. So they might look at the data analytics trends you've found, and their role really is to look at like the broad scheme of things and work out which ones they're going to implement faster or they're going to implement straight away, etc., to work out how the business problems can be solved better. The next one is the project manager. So this person would generally control the project. They would ask you questions such as, did you get this done? Did you do this on time? Could you be responsible for a range of projects? They could be responsible for a range of projects. And unlike the project sponsor, he's more hands-on with the project. Sometimes you'll find that the project sponsor and the project manager are the same person within a company, but as a role and defining a role are not the same thing. Generally, they will ensure that key milestones and objectives are met on time and at the expected quality. So they'll do a lot of quality checks throughout, which is really important within data analytics. The next person is the business intelligence analyst. So this is a person who can know how the system works and how to find information. Where can I find the data for June, for instance? This is located in this report. Generally, the business intelligence analyst is the person that knows everything about the systems within the company that are currently operational. So the person that you can go to and ask where to find something or what to do in this situation. Obviously, if you're doing data analytics, you don't necessarily know everything about that business itself. So having someone that you can just get that context for can be really important. So they provide business domain expertise with deep understanding of the data, KPIs, K-matrix, and analytics from the reporting perspective. Okay. The next person is the data engineer. This is generally the person who knows all around the data based on the module within their systems. They can generally do SQL stuff and they can add joins and transformations and technical tasks within the project. They generally apply deep technical skills to assist with data extraction from sources, systems and data ingestion on an analytics sandbox. So a database administrator is the person that if you wanted to create a report, for instance, you could go to them and then they could set it all up within the database and they could give you some information and feed that information to you. So then you can do the data analyst aspect. Next, you've got a database administrator. So these are the people who set up the data environment and set the infrastructure up to support the module created for the project. They generally have provisions and configurations within the database environment to support the analytics needs of the working team. So you've got the database administrator, which sets up the broad aspects, the hierarchy aspects, and then you've got the data engineer who carries out them tasks. Okay, and then finally you've got the data scientist. So these are the experts who understand the business needs, the business values, and the business problems which need to be solved. From this, they are the ones that will break business problems down into analytical problems and come up with models to solve the problem and can also communicate that problem well. So a data scientist is a very broad job role. So they're the ones that take the business problems at the high level and then they can break it down for a data analyst to do some analysis on. And they can also set the models up so they can set up what you're actually going to be doing within that model itself. Okay. So they provide technical expertise for analytical techniques and data modeling and apply the proper analytical techniques to given business problems to achieve the overall analytics objectives. And very importantly at the bottom it says every role is important. When you're doing data analytics to start off with, all of these roles will at some point be really crucial. Okay, it might be, as we say, it might be one or two people, or it might be one person doing all of it in a smaller business. But it's just a good idea, and also Dell have specified these as the distinct roles within the project. It's a good idea to understand the different things they should be doing. Okay. So when you've got the people, so you've got all the different within the organisation, generally people work with a data analytics lifecycle. Okay. So this ensures that business problems are well defined early on in the project. This could be things such as, what is the desired business outcome? Would you build a model with predictions? Would you have a report generated after something's happened? How will success or failure be determined by a business stakeholder? Who will approve the plan for it to happen? Then you've got, provide the comprehensive, repeatable methods for conducting analysis. So one of the key things within the creation of a data analytics lifecycle is you have a repeatable method at the end of it that you can continuously look over. So obviously data analytics is dynamic, so it's always changing. So having that method is really important at first. It aids communication through key tasks and assignments within the team. it plans and scopes the amount of work involved, and it properly sets out expectations for the project stakeholder. So the last one's important, as generally within analytical problems, the person that's got the business problem to start off with doesn't understand the extent of what that would be in terms of an analytical problem. So it's a good idea to use something such as the data analytics lifecycle, and that just sets out all the parameters to start off with. So data scientists projects involve diagnosing and reframing business challenges as analytical problems and providing solutions to them problems. Many analytic problems seem huge and daunting at first, but a well-defined process ensures that you break complex projects into smaller steps that can be easily addressed. Having a well-defined process for performing analytics also ensures that you establish a comprehensive, repeatable method for conducting analysis. In addition, it helps focus the team's time early in the process on getting a clear grasp of the business problem to solve. So there's a number of benefits that we're going to discuss. The main one for me is that you can break down the project, you can assign different people different tasks to do, you can look at the different steps involved in each of them tasks, and you can also look at the overarching aspects of how the task you're going to then complete can understand the business problem like really well to start off with, and then it can be broken down that way. Okay, so that's why we use a data analytics lifecycle, and there's a number of reasons. So this is the data analytics lifecycle. It's broken down into 6 different areas. You've got discovery, data preparation, model planning, model building, communicate of results, and operationalization. So all these different 6 sections are in a dynamic cycle. So you will do one and then move on to the next one. You'll do one and move on to the next one, etc., etc., etc. Okay. Next to the different boxes, you can see there's just a speech bubble which just asks some of the questions that you might be considering within these sections. For instance, in discovery, do I have enough information to draft a design plan and share it for peer review? These are some of the questions in between the stages that you should be considering. Okay, so you've got 6 stages. You've got exit plans, quality checks, and risk factors to consider during this as well. So you can pause it here and have a quick look over it if you want, but I'm not going to read out all of the questions. So the data analytics lifecycle portrays the best practice approach for an end-to-end analytics process. So it's best practice, so it's not necessarily always going to be correct for what you're going to do. It's just an overview, generic way of doing a data analyst task. It's also an end-to-end analytics approach. So you start off on one section and then you finish at another section. Obviously, in real life and practically, that's not necessarily going to happen. You might do some stages and you might have to come back to a little bit and do a bit more and then go forward again, etc., etc. But again, it's just a generic way of looking at it. There are 6 phases in the data analytics lifecycle. As new knowledge is obtained, movement from any phase from another and back may occur. So you might go from the first phase to the second phase. You might need some more information as you realise when you're going through the second phase. Then you might drop back to the first phase and so on. The circular arrows shown in the image are intended to convey that you can move iteratively between the phases. So here you can see there's some circles in different areas. The only one that doesn't have a circle is when you put it into optimization. So when you do that, generally, it's not quite as easy just to stop it and then bring it back. So that's why you generally only go forward after you've done that. But by that point, you should have evaluated it. You should have gone through all the different elements, and then you should be confident that when you do this, that it's going to work. The callouts represent questions to gauge when enough details are available and enough progress has been made. So as we've again discussed, the speech bubbles have got a few different questions just to consider. So the first stage is the discovery phase. So the key to a business phase is understanding the business problem and what we are trying to fix. Okay, so the discovery phase is literally that, discovering the business problem and then looking at how we can then turn that business problem into an analytics problem. You've got some key activities and discussion points of this phase. So you would have a draft business problem statement where you would look over the business problem and you would define it in as much detail as you can. You would conduct stakeholders and business expert interviews. So you would talk to individuals within that business problem. You would talk to different stakeholders, and you would identify the current business state and any pain points. So a pain point is like a crucial point which needs to be focused on. You would understand what related projects have been attempted in the past. So have they tried to fix this in any way, this business problem? And you would refine the business problem statement based upon all the information that you've received. So obviously the first thing you would draft one, but then you would conduct the stakeholders and then refine it again based upon their input. You would reframe the business problem as an analytics challenge. You would assess resources needed and availability of these resources, and you would then finally draft an analytics plan. So you've gone from drafting a business problem statement at the start and then ending up with a draft of an analytics plan. So a well-executed discovery phase can help you ensure that the proper expectations for the project are set with all of the stakeholders, and the project team members, after some early discussions within the project sponsor and a few different business experts, it is important to document the business problem to be addressed from the start. It's really, really important within data analytics itself is to record everything as you're going along and make sure everything is documented for a number of reasons. We've got the drafting of the business problem statement. So again, there's just a bit more information on here which just goes through the drafting of that business problem statement. The clear things to consider are that you're clearly articulating the current situation and the pain points. You're determining why addressing the problem matters. You're including the intended outcomes or ideal states, and you're tailoring the statement to the key stakeholders. So tailoring that statement to the key holders can be really, really important. Within data analytics itself, the communication and the visualization of stuff can be really important just to get understanding from everyone involved. You're going to be the data analyst, so you're going to understand it, but the CEO or the project manager or the line manager, whoever it is, might not understand it in the same terms you do. So tailoring the statement sometimes to different key stakeholders can be really important. We've got the interviewing of the project sponsors, as we've said. Here's just a list of some of the questions you could have done. You could ask them, so such as like, what's the business problems, what's the pain points, what's your expected outcomes, what's your constraints. It's important at this stage to try and ask open-ended questions. So ask questions that they can discuss in their own way. So such as, what's your expected outcome is really good because that's an open question. If we asked them like, when you run the report 1264, when you press this button, what happens? That's a closed question. So that's asking a direct point of what happens when you do this. And it wouldn't give the person the ability to then talk broadly and tell you what the actual really issues were. And then finding these issues from the stakeholders at this point could be crucial for the whole thing. It's really, really important that you get this stage right. So for example, the project sponsor may focus on a possible solution. They could state something such as, we need Hadop cluster to develop blah, 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 blah. The interviewer should avoid arguing or getting into solution trade-off discussions. Rather, they should say, why? Tell me why. Why is that important? What's the actual problem? So you will find a lot of the time, the people that understand the business problems think that they understand the analytics problems, and they don't. Okay, which is, it's good to an extent because they're trying to have input, but you need to consider it from a point of view trying to find the actual problem itself rather than a solution. It's not about finding a solution. You're trying to find the problems at this stage. Here's some things you can look at when interviewing other stakeholders and experts. So stuff to ask about, stuff like your responsibilities, the pain points, all the different questions, analytical sandboxes. For instance, like analytical sandboxes, you might ask the IT team, what sort of availability have we got for analytics sandboxes? So you might have one that you can test things in. You obviously wouldn't want to test the actual elements on the actual operational infrastructure. So asking these questions to start off with can be really important. Like the analytics sandbox, for instance, it could just be your area on your PC, and you might be doing something within Excel or R programming. You might not have that broad scope to do, but it's a good thing at this point just to consider. Okay. You need to draft an analytics plan, and this document should provide a framework of understanding what has been accomplished so far and how the project should proceed. You need to look at, it's useful to remind the project team about the business objectives and the analytics approach, and as the analytics proceeds, the analytics plan will be updated as often as necessary. It is unlikely that everything will be known at the end of the discovery phase, so keeping it a dynamic document is really important, and the scope also changes, and that will require additional communications with the project sponsors and stakeholders. So the scope itself could change depending on the information you receive from the stakeholders in the interviews, for instance. So it's a good thing at this point just to keep everything open and dynamic, and then from that you can then draft an analytics plan to the best of your ability at that point. Okay. So again, here's just some more information to consider. You can pause it and have a look, and that just goes through some of the key things within an analytics plan you should be looking at. So here's the scenario part. So what we're going to do is at the end of each of the data lifecycle sections, we're just going to consider a scenario. So the scenario is the sales operations team is struggling to provide the sales managers with useful insights and recommendations on the sales deals currently in the pipeline. The company's executives are frustrated with the consistently changing revenue estimates, particularly at the end of each quarter. So the business objectives are the sales operations team is looking to accurately identify which sales deals are likely to be completed or booked in the current quarter, determine which sales deals are at risk, and estimate a quarterly revenue. So that's what the business issue, the business problem, has identified as what they need to be solved. Okay. Within this stage, we've had some interviews with stakeholders and sponsors, and then we've looked at the perceived differences of sale deals forecasting accurately by geographical market verticals, so that's what we need. There's a good look in deals are suddenly dropped or slipped into the next quarter, so that's some of the information you found out. The lack of timely information and advanced warning to ensure deals are closed within the quarter. Then you've got the business problem statement, which is the lack of timely visible into deals are likely to book within the current quarter is prevented from sales from properly focusing on the correct deals and achieving the quarterly revenue goals. So within these interviews, what they've basically said is, so you've got the scenario which is looking at sales, the business objectives is what they're asking for, and the interviews have said that within the whole cycle of the sales, within them quarterly estimates, sometimes they book deals in, or they book sales in one quarter, and they don't actually receive the money till the next quarter, so that there's some lack there of timely information being advanced. That's one of the key things that they found out within the scenario. And they've also perceived differences of sales deals. So the differences of the sales deals, the sales themselves. So if you've got a product which is £10 and it's on sale to £7, that difference there, that £3 difference, isn't being forecast properly or accurately. So it's one of the issues that they're currently having. Okay. Within the discovery phase and the scenario, we found out that within analytics challenges, we need to design a measure for quantifying the risk in each sales deal, and we need to enable the sales team with tools to be allowed to better inspect deal risk, to help move deals through the sales pipeline faster, and to convert high-risk deals to low-risk deals. Okay. The data that we found out that we can access is key data sources via the customer relationship management system to track the sales opportunity. We've looked at other identifiable data sources which provide customer demographics, previous product purchase and installation, services and sales. Okay, so within the discovery phase, this is what we found out. We found out the interview elements, the business problem, the analytical challenges, and the data sources. Okay, so that's kind of what you should be doing within the discovery phase. Within the data preparation stage, you will look at 80% of your time will generally be spent in this phase. Okay, therefore it needs to be communicated. Okay, the data preparation is taking the discovery phase, finding the elements of the data that you need, and then transforming them into elements that you can use as a data analyst. So to start off with, generally what you would do within this stage is you would establish an analytics sandbox, you would extract, transform, load and transform data, you would look at data exploration, data conditioning, you would summarize and visualize the data, and then within that, the project team would be loading the data into the analytics sandboxes, understanding the data set in greater detail, clean and condition the data, and begin preparing the data for the model planning and the business phases and the building phases. Okay, so let's go through a few more of these stages in a bit more detail. So firstly, we will need to establish an analytics sandbox. So an analytics sandbox is like a separate infrastructure that allows you to complete analytics tasks without breaking anything. So it might have a backup, or it might not be connected to the network, etc. You need to consider the size of the data that will be loaded, make sure it's big enough. Plan for the sandbox to be 5 or 10 times the size of the original data. So if you've got data which is 1 gigabyte, by the time you do runs and reports and you do different data analytics aspects, it's going to double and it's going to double again. So make sure it's 5 to 10 times around the size of the data so you can have constant backups. Consider the data and the analytics tools to be utilised. So what tools are you actually going to do this data analysis with? Is it Haddock, for instance? Are you going to address the privacy concerns and security measures? So generally, analytics sandboxes are quite secure because they're off the network, but you need to consider stuff like privacy. And then you also need to work with the IT team to prepare this sandbox to make sure it's done in the way that you need for your analytics tasks. So again, that just breaks it down a bit more that we've just discussed. So you can go through it again if you want. We've got extract, transform, load and transform. So within this stage, we're going to start to look at the data. So ideally, we're going to extract and load the data as stored within the source systems. So we're going to extract it exactly the same as it started as. We're going to ensure the list of variables, including the sandbox, is exhaustive so we've got access to it. And then we're going to transform the data within the sandbox itself. So we're going to start to mess around with, but only when it's in the sandbox. So after the sandbox is established, it is useful to load the data in its original format, which is really important, its original format, or at least with minimal transformations applied to the data. Often, the project team requires assistance from the other organisations to extract this data. If any transforms are performed before loading into the sandbox, the project team will not necessarily have the visibility into the raw data or unfiltered data, which may lead to unintended and misleading results. Sometimes you find within this stage that the data that you've given, or the data that you've been given, isn't quite the same as the original data for stuff like privacy. So you need to consider at this point that if it's not exactly the same, when you run the analytics methods, you might not be running it in line with what the real data would do. So it's just something to consider within that stage. Here's another quick example. So if transactions from an online shopping website are loaded into a sandbox, it is possible that the data will only include the items that were in the shopping cart at the time of checkout. Items added but removed from the shopping cart may be the most important thing within this analysis task, but you might not have access to that data because it's been taken out on the transform into the sandbox. So that's one thing you really need to consider. Okay. The next one is the data exploration elements. So within the preparation stage, you need to consider working with business experts to understand what the actual data means, identifying missing data entries, understanding how the joined data sets or extracts the desired information, and how to identify outliers and possible data quality issues. So a data scientist often plays the role of the detective to understand what the various data elements and values actually represent. The data scientist and a project team should leverage business experts here who are familiar with the data set and the business problem to create an understanding of what that data actually does. The data scientist will be skeptical and validate any assertions that the experts make. So at this point, a data scientist shouldn't take everything on face value. They should try and understand what the business processes are, and the experts are trying to tell them that the data actually is, but not be sidetracked into thinking that some of the things they're saying are the issues of the data analytics problems. So just getting more of an understanding is important here. Then you've got the data conditioning. So after you've got the data in the sandbox, you can join and merge data sets, you can clean the data, and you can normalize the data. So data conditioning refers to the process of cleaning, normalization, and performing transformations on the data in preparation for further analysis. This step deals with detecting and removing errors and inconsistencies from data to improve its quality. So it's just about looking at the data and then working out, is it all in the right place? Can you clean elements of it? Can you join bits to make it more usable, etc., etc.? Then finally, you've got summarize and visualize data. This is probably one of the most important things within the lifecycle. So preparing summary statistics and visualizations to better understand the data. The people, the stakeholders that you show this data to aren't necessarily going to understand it in the same way of you. So making graphs for them, making visualization elements to allow them to understand the problems based upon the ways in which you've dealt with the data could be really, really important. So an example, it may be decided to filter out any apparent duplicate transactions, but these duplications may be of particular value to the analyst. The stakeholder themselves don't need to see the duplicates, but you just keep it there for your records, and it might be something that you can look at afterwards to work out, for instance, why people are taking things out of the shopping cart because it's been duplicated. So let's go back to our scenario then. So as we've said, we're looking at sales, and we've got a few different analytic problems business problems that we outlined within the discovery phase. Now, within the data preparation stage, we have selected Greenplum database as the analytic sandbox. Some data sets were already loaded into Greenplum, and most of the data was already in another SQL database as well, so that's the one we've gone with. There's some data conditioning challenges that we need to consider. There's no historical data on the sale deals that were maintained. Some deals were in a parent-child relationship, so for instance, a deal would ship products to multiple countries or US states, so it's something we need to consider when we're doing the analysis. The completeness of the CRM data was somewhat sale rep dependent, so if the sales rep decided to put the data in, then that was good, but sometimes the sales rep didn't put the data in, so there's gaps within the data itself. Then we've got the data preparation. Within data preparation, we've got the key data to prepare. So the teams ran into several data issues that needed to be addressed from the project for it to continue. For example, the availability of the CRM data only provided the current state of the deals. However, to build a predictive model, it would be necessary to reconstruct the data to show what was in the CRM system 1, 3 or 12 months ago. So at this stage we had to go back to the discovery phase, get some more information, and then we could head back into this one. So next is the model planning. So based on the analytics challenges that we've set out and the data that we've prepared, the project team selects a possible analytics model and the corresponding variables and other inputs. This model planning phase may seem straightforward, but is often necessary to perform extra data exploration, data conditioning and transformations to prepare the data ready for the model building. So are you going to look at this data or both sets of data, for instance? So even though you've got the data there, what are you actually going to use within that data? So within this model planning, you should explore the data and understand the relationships amongst it. So you should start to link elements together. You should question and evaluate opinions from stakeholders and domain experts again to make sure you've got the right sort of data. You should identify relationships and correlations, for instance, amongst possible input variables or between input and outcome variables. You should leverage a technique for dimensional reduction if applicable, and you should perform additional data transformations to perform carryable data for modelling. So on the right hand side you've got data, for instance, which has been thrown into a bucket, which has got a set of variables which you then need to put that data into, and then when you put it into that, then you can start to analyse it properly. Okay. So within this stage, we're going to select the model. So within the planning, we're going to choose an analytical technique of a short list of candidates based on the purpose of the analysis and the types of input and output variables. So the purpose, we're going to look at stuff like, are we going to create an exploratory analytics solution, or we're going to look at predictive or descriptive or predictive. We're also going to look at the types of input. So what sort of data is going into the analysis? What sort of data do we need to get out of the analysis? Is it categorical to start off with? Do we need to break that more down? We need to also consider to decide to fit one model of a series of models. So, for instance, one regression model to handle 50 US states. So if we had 50 US states, would we do one regression model to handle all of them, or would we do 50 different ones and then one model for each individual state? And then finally, another example of that to make it a bit more clear is if you had some data, would you do one model on that data in order to try and get your result, or would you do a series of different analytical problems on that one set of data in order to put all them together at the end and then get a main result? And then finally, to determine the analytics tools to fit the selected model. So the model itself is the important thing. When we've got a model, we can decide what sort of analytics tools we need. We're going to have an environment, so such as Greenplum. Then we might have a model, a predictive model, or we might have something along them lines. And after that, we can then select some of the analytics tools that we're then going to use to allow us to achieve that model. So the main goal is to choose an analytics technique or a short list of candidates based on the end goal of the project. It is often useful to revisit the analytics challenges at this stage of the project to ensure that analytics challenges is still relevant and that there is no any scope creeped into the project. So it's just important at this point to make sure that you continuously go back to that business problem and make sure you're solving it. A lot of times you get to this point and you get a bit sidetracked. So you might say, I want to do this model. I can do this, I can find this information out. You could create the best model in the world. If it doesn't find the actual information you need in order to fix the business problem, it's not the correct information. Again, within the scenario, the team decides to classify each sale opportunity into one of three categories: a book, push, and a close. So the book is sale deals that are booked into the current quarter, a push is a sales deal which will be deferred into the next quarter, and the close, which is the existing opportunity, will not result in the booking of any quarter. Alongside this, they've decided that a multi-nominal logistic regression model will be selected. The model output provides a probability for each of the three categories, and the opportunities can then be ranked to determine priorities to the sales team. So this is the model that's been chosen, based upon the data we've got and what we need to achieve based upon the business information. The next stage is the model building itself. So in the model building phase, the selected analytics technique is applied to a set of training data. This process is known as training the model, or it could be pilot study is another one that is used, or pilot test. So a separate set of data, known as testing data, is then used to evaluate how well the model performs. This is known as pilot test. Often, the fitted model is to be applied to further observations, so it's not sufficient to obtain the best model that explains all of the data. You must build a model that adequately predicts future events. Okay, so at this stage we're using a range of, so if we've got 10,000 pieces of data, we might use 400 pieces of them data to use as our pilot test. It's not necessarily going to be perfect, but it's a good way to test your model to begin with. So a typical approach to this is you would randomly select a subset, say 70 to 90% of the available data, to train the model and make sure it's working correctly. That will then become your training data set. Using the remainder data set, that will be your testing data set to evaluate the performance and fitting of the model. So it's important to have two different data sets, and it's important that they don't cross. The reason that we don't just use all of the data is because you could set up a model to start off with, and then you could run it as your training data. You could think it works completely, and then when you use the actual data, it doesn't work. So allowing it to have this separation just means that you've got another set of data which is completely separate that you can then test it with and make sure it works on different sets of data. Some of the additional considerations are to apply stratified random sampling to ensure proper representation for all groups, and does the modelling technique implicitly account for the training and testing data set? So just some more things to consider. Like stratified random sampling, for instance, is just a way of taking all of the data and making sure that the sample groups you make are broad enough to cover all aspects within that data. So we need to build and test that data set. So here's just a bit more information, a bit more maths on how you would actually go about doing that. So often the building of the training data set and the testing data set is fairly straightforward. You would generally use a proper random number generator, randomly assign a number 0, for instance, through to 1, and then each record is in a data set. You would select the records corresponding to the smallest percentage, for example 80%, and then 80% of, smallest percentage, for example, and then 80% of the assigned numbers, this data set then becomes the training data, and then the remaining 20% becomes the testing data. So it's just ways to separate it. The importance of random sampling is that the entire data set may already sequentially have attributes such as customers, geographical elements, and time. So using the first 80%, for instance, would be biased. So you need to make sure you separate it in a random way. For instance, if we were doing something about postcodes, they'd all be in a certain order. So you doing it to the top 80%, you might work out that the bottom 20% has 2 different digits. So it wouldn't be appropriate for you to do a data set which is just from start to 80%. Then we've got the test. So sometimes it might be necessary to deploy a method such as stratified random sampling, as we've discussed. In some more advanced analytic modelling techniques such as random forests, the technique itself randomly extracts the data for you. It fits it to the model and tests the model. This process is repeated several times. So instead of just separating it once, you'll separate it into different random sets loads and loads of times, and then that's a better way of doing it, but it produces more data, it makes everything bigger, and it's slower. So it's a balance. Next is the evaluation of the model. So is the model accurate enough to meet the goal? Are there edge cases that are not properly handled? So is the data around the data that doesn't fit into the model and it's just not done anything with it? And then does the model output behaviour make sense to the domain experts? So after you've done all of this, the actual output from it, does that make sense to the stakeholders? Or do you need to do it a slightly different way? Okay, so within our model itself, what we've done is we've got 104,000 different cases. We've separated 70%, so 72,000 into our training data set, and then we've got 31,000 for our testing data set. We've also built an initial model of multi-nominal logistics. We've based it on domain expert feedback, so they've asked for the direct sales team will create price quotes well in advance of the deal booking, so this is what they've asked for and this is why we've done some of the things. And then you've got the sales data is stratified into 3 groups: data sales, indirect sales, and other sales. So all this data that we're going to put in and put out in our model is going to give us more information. So after the multi-nominal logistics model was fit to the data and the project team was satisfied with the results, the model results were shared with several domain experts. Quickly, it became apparent that several input variables and the timing of their additions to the CRM system depended on which sale groups was managing the deal. So it was decided to build a separate model for each sales group. To split the data into 3 different groups, it was necessary to exclude around 6,000 deals from the analysis. This legacy data was not clean enough to properly categorise the deals. Training and testing data was built for each group, and each group's model was trained and validated with an overall accuracy of 88%. So again, we're doing some analysis here on our model itself, just to see how it's working. So again, this breaks it down a bit more for you. So we've got 104,000 cases. We've separated it after we've got rid of the 6,000. Well, we've not got rid of them, but we're not using them because it doesn't fit into the category. It could be stuff like spelling mistakes, or it could be parts of data that's been recorded that we don't need. We've got 26,000 on direct deals. We've got 61,000 indirect deals, and we've got 10,000 on other deals. Overall, we've got an 88% accuracy on the validation set, and the number of clean deals eligible for modelling are falling into that category. Next, we've got the communication. So at this point, we've done all the data, we've discovered everything, we've prepared it, we've done modelling, and we've built everything. And now it's about communicating that data. This is the most important stage. you can do lots and lots of discovery, do some really good analytical problems. If you can't communicate the results to the stakeholders, they can't then solve the business issues with them, and then the data comes redundant. So after an acceptable model is obtained, the next step is to communicate to a project sponsor and the stakeholder within that project the project's findings and the business values of that model. If its desired business outcomes were not obtained, this result also must communicate the prepared presentation for sponsor analysis and share the project results with various audiences. So it might be a case on this stage is you might do a few different types of communication elements for different stakeholders. They might want to know different information. So for instance, within the sales team, the actual sales people themselves might need to see what sort of data they're currently working with in this quarter, whereas the boss and the CEO might want to see the overarching data and work out whether they're making more money. So they've got different things they might want to see based upon your data. So it's important to prepare presentations for sponsor and analysis and analysts. So to state the business problem and the objectives of the analytics problem, to provide the business values and the implementations of the model, and prepare recommendations for the next step. So at this stage, you would generally be giving the project manager or the client or the sponsor a set of recommendations as to how you can now input this into operational elements. So while the communication results phase may seem to be the simplest and the most straightforward, it can often be the most challenging part of the exercise. The team must not only provide the outcomes for their efforts, but in some circumstances, they must also overcome the stakeholders' preconceived notions of what the most influent input variables are. So looking over a lot of different analytical methods, a lot of the times in this situation you get scenarios. So for instance, furthermore, unless the project sponsors and stakeholders are kept periodically updated on the project as well, you get typical responses such as like, this isn't what I've asked for, I've asked you to look at this problem. You get these issues, so it's good to communicate all the way through the project to make sure everyone knows that you're on track, which is really important, and you're pushing the business problem the right way, but your answer might not be what they want. So for instance, on that sales report, for instance, the boss might have said, well, that all my staff are just not recording the data properly and therefore I can't access it. So they've got a preconceived notion that the issue behind that is Bob and Steve in the corner are a bit lazy and they can't really be asked putting the data in. Okay, that's their preconceived notion. What the actual issue is that the data is not recorded in the right categories. So it's recorded, but it's not recorded in the quarter it's been booked in, or when the sale money's gone through, etc., etc. Okay, so making sure that you need to be convincing here. You need to convince them this is the reason. We've done this analytical problem-solving exercise, and we've done different analytical models, and we know at this stage this is how to fix your business problem. Within this communication and results, we need to share project results with various audiences, as we've discussed. So it could be a range of different people. We need to build a strategy to communicate these findings and present the findings to project sponsors and stakeholders. This is how we've done it within our project. So we've looked at the big picture, the takeaways for the executive leads. We've determined key messages to aid their decision-making processes. We've focused on clean, easy visuals for the presenter to explain and the viewer to grasp. And our main objective is to demonstrate the business benefits of implementing the model. We've got a different presentation for the analysts, and this looks at the business process changes, the reporting changes. The fellow data scientists will want details of technical graphs, for instance, and then our main objective here is to demonstrate the validity of the model. So we're not talking about the actual business problem now, we're talking about how you would then implement that. And then also we're going to discuss the code and the technical specifications. So here's a quick example of how the modelling process could be communicated to the various amounts of audiences. So number one, you've got the broad range of opportunity data to collect, so you've got loads of different information that we've caught. you've got information that we've caught, such as sales opportunities, product purchases, quote information, booking data, rep characteristics, service history, and other relevant data. Then we've got data is run through the analytics model. The model outputs some key input drivers, and then from that it puts it into categories. Okay, so this is just a way you could display it. So this is something you can actually build, and you could show the CEOs this is what we're doing. And instead of just explaining it, you could show them this picture and you could walk them through it, and it would make more sense. And finally, you've got the operational element. So after the stakeholders have agreed to implement the model into production, the operationalization begins. So depending on the organisation, the project team may be responsible for the model's implementation, or they may simply transfer the code and technical documentation to a different team. In either case, it is important to bring up any new participants up to speed here during this phase. The reason that's in is because sometimes when you get to this stage, you've got everything ready and done, you just give it to someone and say, put this into service for me in the infrastructure. They might not quite understand what you actually want them to do and might do it slightly different, and therefore it will mess the model up. So at this point, it's good to establish that approach and to monitor it and then be involved in it as well. Within that, you need to provide code and technical documentation. So making sure you've commented your code, for instance, you've got different documents that talk through different elements of the code, making sure that document's set up correctly. You've got any onboard new team members to consider, and then then the final bit is to actually deploy the model and then monitor it. So deploy the model in a test environment, run the pilot projects, determine some monitoring of the implemented model, and then recalibrate the model based on feedback to make sure it's working correctly. So this is really important. So after the model is placed into production, it's often necessary to monitor the model's performance and establish a process to retrain and update the model continuously, because year on year stuff might change and then you might have to change the model slightly, but it's a good idea to have an understanding about that. Okay. It should be noted that further communications of results often occur during the operationalizational phase, and the executives, for instance, might want to know what the actual ROI of their investment is. Okay, so it's something to consider is the implementation of your analytics model. What's the actual result from that based upon the business problem? Are they making more money? Is it making it more efficient, etc., etc.? Within our scenario, we're using a developed models. A process was put in place to update the deal's predictions per week. The results were packaged into an easily consumable set of documentation, and the approach content was shared with the sales reps, sales managers, the regional directors, and then so on. The model was implemented into a process to provide weekly updates of the likelihood of deals being successful, and the project results presented here were just some of the initial successes that the sales organisations realised. So, that's the data analytics lifecycle. Each of the stages are really, really important. However, understanding the general gist of them all, as a data analyst, you might not do all of these yourself. You might only do certain parts of it, but understanding how it all works together is really important. That is the end of the presentation. So I'll leave it on that slide just so you can see it. So make sure you consider each of the stages individually. Hopefully this presentation has just gone over the different stages, and it's just give you more clarity as to what you're going to be doing. Within each of the stages themselves, make sure you read over them, make sure you understand the theory behind them, and then the general gist of what you're going to be doing within that theory, and then you'll be fine within this section. Okay, so thanks for listening to the video on the data analytics lifecycle.